synthesis of trisubstituted benzenes. When you want to synthesize trisubstituted benzenes from disubstituted benzenes, then you have to consider the directing effects of the two groups. For example, let's say that you want to do the nitration on paramethyl nitrobenzene. So here are the two groups, and you want to put the second nitro group on this molecule. But where is the second nitro group going to go on this molecule? For that, we have to identify the directing effects of the two groups, methyl group and the nitro group. Methyl group is weakly deactivating, which is going to direct the incoming electrophile onto the ortho and the para positions. Right? So here are the ortho and the para positions. But the para position is already occupied, so we'll be having the substituent going only to the ortho positions. But what would be the effect of this nitro group? A nitro group is strongly deactivating, or in other words, it's a meta director. The meta position with respect to this nitro group is also this carbon. So both of these groups is going to direct the incoming electrophile onto this position. So you get the nitro group on one of those carbons. Right? So this would be the product. Both substituents direct to equivalent positions. In the next example, we want to nitrate metachloromethylbenzene. Okay, the incoming electrophile nitro group, where is it going to go? So for which we have to consider the directing effects of these two groups, methyl group and as well as a chloro group. Let's find out what would be the positions that will be nitrated with respect to methyl group. A methyl group is an ortho and para director. So let's find the ortho and the para positions with respect to this methyl group. So here are the ortho positions and here is the para position. So let's highlight this. So this, and this. These positions can get nitrated. The next group is chloro group. So the chloro group is also an ortho and para director. And with respect to the chloro group, here are the ortho positions and this is the para position. Basically, both of these groups right here are directing the incoming electrophile onto the same positions. Now let's write down the three products that we'll be getting. Here are the three products that are obtained, and out of this we can definitely say that this is the product that is formed in low amounts. So this would be the minor product. Why? Because the nitro group needs to get inserted between these two groups and there is lots of steric hindrance, right, if it's going to get inserted between these two groups. Right, so this would be the minor product, and the rest of the two products will be formed at relatively higher amounts, and that is what we see here. In both the examples that we have seen earlier, both of the groups in the disubstituted benzene were directing the incoming electrophile onto the same positions. Now let's take a look in this compound. Where is the new electrophile is going to go? So here we have an OH group. The OH is an ortho and para director, which means here are the two carbons where the incoming electrophile is going to go, right? But the para position is occupied, so this is already occupied, so we'll not be worried about it. So these are the two positions with respect to the OH group. When it comes to the methyl group is again an ortho and para director, but its ortho positions are different. So when it comes to the methyl group, these are the ortho positions. Let's highlight this. These are the ortho positions, and again the para position is occupied, right? So there cannot be any substitution that will be happening here. Now between these two groups, which of these effects is going to predominate? The OH is a strongly activating group, whereas the methyl group is a weakly activating group. Now because the OH is a strongly activating group, the incoming electrophile is going to go on to one of these positions. So the product here would be this. One last example, nitration of para-ethyl methylbenzene. Here we have two alkyl groups and both of them have again the same effects, right? So this is ortho and para directing, and this is also an ortho and para directing. With respect to this methyl group, these are the two positions that will be nitrated, and with respect to this ethyl group, these are the two positions that will be nitrated. Here, there is no dominating effect. Say, for example, both of these alkyl groups are going to have equal preferences in directing the incoming electrophile. So in which case, both of these products will be formed.